Welcome to the RHEL10 Network Troubleshooting Lab. In this session, we will identify an IP address conflict on a remote server, step by step. An IP conflict happens when two devices on the same network are configured with the same IP address. The result is chaos. Traffic bounces between the two devices and the server becomes intermittently unreachable. By the end of this lab, you will be able to detect such a conflict, find the offending device, and fix it safely, even on a server you can only reach remotely. Here is our lab environment. You are the administrator. Your workstation is at 192.168.10.100. The remote RHEL10 server, Web01, uses interface EN01 with the address 192.168.10.10. Now, someone has connected a rogue host and wrongly given it the same static address, 192.168.10.10. The symptoms you notice. Ping replies come from two different MAC addresses. SSH sessions randomly drop, and the web service fails intermittently. Remember the golden rule. If a remote host becomes unreachable in bursts, suspect a duplicate address before you touch anything else. Step 1. Establish access and verify the configuration. Because SSH may drop mid-session, first connect through the console or out-of-band management. Then verify what IP address the server thinks it has. Run IP-BR address show for a brief listing of every interface. Notice that EN01 is UP with 192.168.10.10. Next, check how that address was configured using NMCLI, Network Manager's command line tool. This tells us whether the address is static or from DHCP, which matters for the fix later. If the interface state ever shows DAD failed, the kernel's duplicate address detection has already fired. Step 2. Let the kernel tell you. The Linux kernel performs duplicate address detection automatically and logs every conflict it sees. Check the kernel ring buffer and the system journal for the word duplicate. On RAEL10, run journalctl-k-b and filter with grep-i duplicate. You are looking for a message like IPv4 duplicate address detected. This logline already names the conflicting MAC address, so write it down. If the journal shows nothing, the conflict may be intermittent. Widen the window with journalctl-k, since today, or grep through the messages log. Step 3. Inspect the ARP neighbor table. Every IP address this server talks to is cached in the neighbor table. Run IP-s ni show. Normally, each IP maps to exactly one MAC address. A duplicate address makes the table flap. The same IP alternates between two different MACs and entries switch to failed. That flapping is your smoking gun. You can also watch live with IP Monitor, which prints neighbor updates as they happen. That is perfect for catching an intermittent conflict in the act. Step 4. Prove it with ARPing. ARPing sends raw ARP probes, so it does not depend on the server's own traffic. First, run ARPing with the capital D flag for duplicate detection. Sudo ARPing-D-I EN01-C3, followed by the IP address. If another device replies, the address is already taken, and the exit code of 1 confirms a duplicate. Then run a normal probe with -C5. Look closely. Two different MAC addresses reply for the same IP. There's your conflict, captured in 5 packets. Step 5. Catch the culprit live with TCP dump. Start a capture on the interface. Sudo TCP dump-I EN01-ERP-NN. The E flag prints MAC addresses. While the capture runs, both devices announce themselves, and you will see two different MAC addresses claiming 192.168.10.10, one after another. Count how often each one speaks. The louder device is usually the one stealing your traffic. Stop the capture with Control-C once you have enough evidence. Step 6. Identify the offending device. The first 3 bytes of a MAC address are the vendor OUI. Look it up online with curl against an API such as api.macvendors.com. Then scan the whole subnet. Sudo nmap-sn 192.168.10/24. This lists every live host with its MAC address. Find which device carries the rogue MAC and check your DHCP lease file for that MAC as well. If the rogue device sits on the same switch, LLDP can even tell you the switch port, so check the output of LLDP tool. Step 7. Resolve the conflict. First, disable the duplicate on the rogue device. Remove the static IP, or change it to the address it should really have. Then, on Web01, flush the stale ARP entries so the server forgets the wrong MAC. Sudo IP-s-s nay flush all. Verify with rping-d again. No reply means the address is now unique. Finally, confirm the service is stable. Ping the server for a few minutes and reload the web page. For a quick test, you can also change the address temporarily with IPADDRDEL and IPADDRAI, or use NMCLI to make the change permanent. Finally, prevent it from happening again. Use DHCP reservations instead of scattered static addresses. Always pre-flight a static IP with rping-d before you assign it. Keep the kernel's duplicate address detection enabled. On RREL 10, it is automatic. Watch for neighbor table flapping with a simple monitoring script, and document every address in an IP plan. To recap, check the kernel logs, inspect the neighbor table, prove it with rping, capture it with TCP dump, identify the MAC, and fix the rogue device. Congratulations, you have just completed your first real-world IP conflict hunt on RREL 10. Happy troubleshooting.